In this lecture, I am going to discuss on the topic Z parameters of two-port network representation. In this lecture, you will learn how to represent two-port network using Z parameters. What is Z parameters? Z parameters actually represents the impedance parameters. It is called impedance parameter because the different Z parameters values are calculated by dividing the voltage by current. We know if you divide the voltage by current, we are getting the impedance. Impedance parameters is commonly used in the synthesis of filters, and it is also useful in the design and analysis of impedance matching networks and power distribution networks. The two-port network may be voltage driven or may be current driven. See in this figure, the upper one shows the voltage driven two-port network and the lower one shows the current driven two-port network. So in the first figure, in the upper figure, two voltage sources are connected across the input port and output port. V1 is connected across the input port and V2 is connected across the output port. And the lower figure, two current sources are connected. I1 current source is connected across the input port. I2 current source is connected across the output port. The black box is replaced with Z parameters. So within the rectangular box or within the black box, 4 Z parameters are shown: Z11, Z12, Z21, Z22. The two-port network is represented by these 4 Z parameters, and at the input port we are getting V1 voltage and input current is I1. At the output port we are getting V2 voltage and output port current is I2. So 4 variables are there: V1 I1, V2 I2. Here V1, V2 are the dependent variable, and the dependent variables, the value of this V1, V2 are depending on the values of I1 and I2. We can represent the V1, V2 in terms of I1 and I2. We can write V1 equal to Z11 I1 plus Z12 I2 and V2 equal to Z12 I1 plus Z22 I2. These two equations are useful to find out the different values of Z parameters. So in matrix form we can represent voltage matrix equal to Z matrix into current matrix. The voltage matrix actually represent the input port voltage and output voltage. It is a 2 by 1 matrix. The Z matrix represent the different Z parameters, and the current matrix represent the input port current and output port current. It is also a 2 by 1 matrix. The Z matrix is 2 by 2 matrix. So to find out the different Z parameters, we will apply two conditions. In one condition we will open circuit the input terminals, and in another condition we will open circuit the output terminals. When we open circuit the input terminals, I1 becomes 0, and when we open circuit the output terminals, I2 becomes 0. These two conditions are needed to find out the different Z parameters value. So from equation 1 and equation 2, we will find the different values of Z parameters. From equation 1, see, from equation 1, if you want to find out the value of Z11, we have to make second part 0. To make the second part 0, we have to make I2 equal to 0. If I2 equal to 0, the second part becomes 0. Then the value of Z11 is equal to V1 by I1. Similarly, when I2 equal to 0, we will also find the value of Z21. Z21 equal to V2 by I1. So when I2 equal to 0, we are getting the Z11 and Z21. When I1 equal to 0, if the input port is open circuited, then I1 becomes 0. If I1 equal to 0, then we will get the value of Z12 and Z22. So all these values we are getting by using the equation 1 and equation 2. Here Z11 is known as the open circuit input impedance. Z12 is known as the open circuit transfer impedance. Z21 is known as the open circuit transfer impedance. Z22 is known as the open circuit output impedance. See, Z11 equal to V1 by I1, where V1 is the input port voltage and I1 is the input port current. So that's why Z11 is known as the input impedance. Z21 is the V2 by I1. It is known as the transfer impedance because I2 equal to 0. I2 equal to 0 means output port open circuited. When output port open circuited, we are getting the V2 voltage across the output port, and here I1 is the input port current. So we are getting the value from second port or output port and current from the input port. That's why it is known as the transfer impedance. Similarly, Z12 is also a transfer impedance parameter and Z22 is the output port impedance. Z22 is the output port impedance because we are getting the value by dividing V2 by I2. So V2 is the output port voltage, I2 is the output port current. So that's why Z22 is the output port impedance.